So now to the meat of things. Irregular shapes, such as pentagons, or those weird L shapes that you sometimes see on the EOGs, or the weird L shape that my classroom seems to be in now that I've looked at it. Finding the area of this is a little trickier because there is no formula you can use. There's no formula for the area of a pentagon. There's no formula for the area of a hexagon, octagon, or this weird L shape that my classroom is in. What you have to do in order to find an accurate square footage of those areas is you have to break those shapes into shapes that you can find the area of. Once you have broken them up and found the areas of those smaller sections, you add up your totals. Let me show you a couple of examples. The first shape over here to the left is more or less the shape of my classroom. It's got a small little alcove and it's got everything else spread out inside of it. This shape over here is just an ordinary pentagon, or more or less it's the way that you might draw a house. Those are two ways that you might see irregular shapes, but I've got a couple of better examples ready and waiting for us. Let's check them out. So this is a problem that actually came up on a recent homework assignment that I handed my class. This shape has a nice L shape and it wants to know the area of the unshaded part of this figure. This problem threw a lot of my students for a loop, and I want to work through it with you guys. Step one is to try to find a good place to make a cut on this shape. You really do have two options here. You can make one vertical cut right here, or you can make one horizontal cut right here. But otherwise, you don't need to do much. I'm going to go ahead and I'm going to make a nice horizontal cut right here. Next, I need to find the area of my two large rectangles. This rectangle down here seems to have a base of 4 centimeters and a height of 2 centimeters. What I'm going to do is I'll take my base and my height, multiply them together to get a total of 8 square centimeters. I'll write 8 centimeters squared. And that's my area of that smaller rectangle. Next, I need to find the area of this larger piece right here. So, there doesn't appear to be a base down here, so let me look someplace else. Okay, up here at the top. It's got a nice long surface at the top that goes along the entire length of the rectangle. This is the number that's going to be used as my base, 7 centimeters. Next, I have to find my height. While it is tempting to use this 6 centimeters off to the side, you need to consider the fact that this 6 centimeters is not simply the height of this rectangle. This 6 centimeters is the height of the entire shape. We don't need any of this space down at the bottom because it's already been used for this rectangle. Instead, we're going to use 4 centimeters, this digit right here. We're going to multiply 7 centimeters by 4 centimeters in order to get 28 centimeters squared. We'll write 28 cm squared. And that only leaves one more part. You see, many of my students put 36 as their answer for this question because they missed one piece of information from the question. It said the unshaded part of this figure. As you can plainly see, there's a square right smack in the middle that is shaded. We have to cut that out. So, what you had to do at the very end was you had to find the area of this little square, which 2 by 2, it's fairly simple. The area is going to be 4 centimeters squared. Finally, you're going to add the total area of everything, which would be 28 centimeters plus 8 centimeters. That's going to give me an answer of 36 centimeters. 36 minus the shaded part, because we don't want the shaded part. So we're going to subtract 4 centimeters, giving us a final answer of 32 centimeters squared. Final answer. Everybody okay on this problem? Let's take a look at a different example of what this might look like if it were to appear on a graph. Here's another problem that seems to give a lot of people trouble. I wasn't originally going to talk about these sorts of shapes if they appeared on a grid, but after watching some of my students take a crack at it, I decided it might be worth going over. If a shape were to appear on a grid, a lot of times I'll see my students counting these lines. They'll say 1, 2, 3, 4. Okay, this shape is 4 units high. And unfortunately, they're wrong. Any of you at home watching this who are my students and just realized your mistake? Sorry. What you actually have to do is you have to count 1 block, 2 blocks, 3 blocks. The height of this shape is going to be 3 blocks. Next, we'll find the width of the rectangular part of this shape, which would be 1 block, 2 block, 2 blocks. So, as you can plainly see, this is not a regular shape. It's irregular. So we're going to draw this line straight down because that seems to be where my rectangular shape ends and where my triangular shape begins. So, since this is a rectangle, we do know that the height of it is 3 and the base is going to be 2. Nothing more to do there. Let me switch to a different color for our triangle. We don't really need the dimensions of this shape. A lot of my students were a little confused and very concerned whenever they saw this shape on a grid. They weren't totally sure what to do with this diagonal line. And to be honest, you don't need to be concerned with it. You don't even need that at all. What you do need is the height, which, if you were paying attention, shares the side of this rectangle, meaning the height of this triangle is 3. And if you still remember how to count, you should be able to figure out that the base of this triangle is 2 units. Now it's just a matter of finding the square footage of both areas. The rectangle has a base of 2 and a height of 3. Parallelogram's area is found by using base times height. 2 times 3 gives me an area of 6 units squared. Next, we take the base of my triangle and the height of my triangle, and we multiply it, 2 by 3. That gives us 6 as well. Once we've got that, we need to divide by 2 because we're dealing with a triangle. The area of a triangle is base times height divided by 2. So we take 6 divided by 2, giving us 3 units squared. We add them up to combine them so that we've got the total area, and that will give us a final answer of 9 units squared. And that's all there is to it. Doesn't matter if it's on a grid or not. Let me give you one more example, something for you to work on your own. Here's a trapezoid. In this case, it's already been cut up for you. They have all of the dimensions you would possibly need to solve it, all set and ready to go. Go ahead and take a moment to pause the video here and try to find the square inches of this shape on your own. I'm going to go ahead and count to 3, and by the time I get to that 3, this video needs to be paused and you need to be working this out all on your own. Okay? 1, 2, 3. Yeah, I'm not done yet either. I'm just stopping right here so that to make sure that you can do a progress check and see that you need to have, for the area of this rectangle, an area of 48 inches squared. All right, I'll count to 3 again. The next time this video moves on, we're going to have the area of one of these triangles. 1, 2, 3. So as you can see, the square inches for that triangle is not going to be 12 inches squared. I went ahead and unpaused it right here, so that way you can clearly see that we should have 6. The reason being is, think back, the area of a triangle is supposed to be base times height divided by 2. You had to do 2 times 6, which would give you 12, and then divide that by 2 to give you 6 squared inches. Which I suppose there should be no mystery. This line is the same as this line over here, seeing as it is a rectangle. Which means that the area of this triangle is exactly the same. Your final step should have been to combine all of these to get your final answer. Go ahead and finish it up by solving it and getting your final answer. I'll go ahead and count to 3 again so you can pause. 1, 2, 3. All right, your final answer for this trapezoid should have been a total area of 60 inches squared. Everybody got that? All right. Well, that's all the information I've really got for you guys today. I hope you found all of the information informational. All right, guys, that's all I've really got for you today. Area of polygons and a little refresher on perimeter. If you need any more help, feel free to rewatch this video or check out that website I mentioned in a previous video. It's ixl.com. They've got a whole bunch of really awesome example problems that you can work through, and best of all is that it'll tell you the right answer and tell you exactly how you were supposed to get that right answer if you got a question wrong. They've got stuff ranging all the way from kindergarten up through, I believe, 8th grade. So jump on, check it out. It's free. And in the meanwhile, I'm Mr. A. Have a nice night.